Video 3 is going to be all about reflections here. So this is going to be our first transformation that we're going to learn, and we're actually going to get on the graph and do some of these transformations, learn the formulas, and how these reflections affect kind of the coordinates. So by the end of this video, you should be able to define a reflection, perform a reflection over the x-axis, y-axis, y equals x, or horizontal or vertical line, identify a reflection given two images on a coordinate plane, and determine if two images underwent a reflection. So first, let's talk about what a reflection is. So a reflection can be thought of as folding or flipping an object over the line of reflection. All right, so a couple key things to know about a reflection here. It is a rigid motion, which we talked about in video 2. It preserves distance and angle measure, which again is part of it being a rigid motion. And the last one that's kind of new is it does not preserve orientation. This is the only transformation that does not preserve orientation, and we're going to talk more about orientation specifically in the next definition. So if we talk about reflection, there is always going to be a line of reflection. So in this case, I'll give an example here. This is going to be my line of reflection. It's going to be the line that I'm going to flip this image ABC over. So we have A prime, B prime, C prime. Okay? Actually, I have that wrong. This should be B prime, and this should be A prime. So it's these little marks mean here. All right, so the way that they're going to talk about a reflection is going to be a lowercase r, and then down here is going to be the line that you're reflecting it over. You'll see the notation as we get a little further in this video. All right, so orientation. Orientation is the relative arrangement of the points after a transformation or after traveling around a geometric figure. The best way that I like to describe orientation is the order of the points if you're going either counterclockwise or clockwise. So what you'll notice is in this image, if you start at A and work your way counterclockwise, you go from A to B to C. Now, in order to have this same exact order in this other triangle, you would have to go in the opposite direction. You have to go clockwise in order to get that same order. That's what it means when it says that orientation is not preserved. If orientation was preserved, I could go counterclockwise in both images and have the same order of letters. Since the order of the letters changes, that means that this does not preserve orientation. I'll show you a transformation that does preserve orientation when we get into the next video. So let's talk about how we actually perform reflections. So first, let's reflect this point 4, 2 over the x-axis. So first I'm going to plot the point P as 4, 2. And again, we're reflecting over the x-axis. I'm just going to highlight it here so you can see a little bit better. The first way that I teach people how to do reflections is just to count. So a reflection means it's going to be the same distance on both sides of the line of reflection. So if I count from P to the x-axis, I can see that it is 2 coordinates away. So I'm just going to count 2 more coordinates, and there's going to be my image P prime, which is going to be the point 4, comma, -2. So that'll be helpful later when we start to talk about the formulas. All right, so next one, let's reflect it over the y-axis. Again, let's start with 4, 2, point P. Again, my y-axis is here. And again, I'm just going to count. So in this case, we have 1, 2, 3, 4. And I would count again, 1, 2, 3, 4. And this would be P prime. So my new P prime is going to be -4, comma 2. And again, pay attention up here to what's happening to the coordinates. That's going to be the easy way to remember the formulas when we get to them. Next one is reflect point P over the line y equals x. Now, you don't have to graph this line because I'm going to give you a formula to do this. This would be the line y equals x. All right, the coordinates 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Now, if we're ever going over a line that's slanted like this and you did want to count it out, okay, you would count up to the line, 2 spaces, like this one is, and then you would count to the left. So this would be my new point P prime. So those coordinates are actually 2, comma 4. Right, but again, I'm going to give you a formula down here with the rules that you can memorize to make these a little bit easier. This last one, this fourth example, is the only one that does not have a formula. This one you must graph. You have no choice but to graph this and count it. It's the only way to do this one. So again, we'll start by graphing point P at 4, 2, and I must graph this line x equals 1. And as we went over in video 1, x equals 1 is going to be a vertical line. And since this is my line of reflection, I'm just going to count 1, 2, 3 spaces to the line, and 1, 2, 3 spaces after the line. That's point P prime. So I have a new coordinate of negative 2, 2. All right. So this may seem like a lot, and it may seem like a lot of counting, but the nice thing here is these are the 4 different rules that you can memorize. So reflection over the x-axis, all you do is it goes from a point x comma y to x comma negative y. That just means change the sign of the y value. So if the y value is positive, make it negative. If the y value is negative, make it positive. All right. And then our reflection, the y-axis, we take the x value and we change its sign. So this one simply just changes the sign of the x value. Okay. Reflection of the line y equals x, you just flip the coordinates. So you just not flip the signs, you flip the order. So you make the point from xy to yx. So you don't change the sign, you just flip the 2 values. Okay, and this last one comes up every once in a while. So this one we flip and change both. Very rare that you see this one. It doesn't come up a lot, but it's definitely helpful to know just in case. All right, so our last example, this is probably what it's going to look like either on your mastery check or on a test. All right, so given triangle ABC with vertices A, B, and C, first step here is graph triangle ABC. So I'm going to graph point A, point B, point C. All right, so this is my first triangle. And one thing that I like to do with all of these questions is I like to list my coordinates out because it's going to help me when I go to do the transformations if I don't want to count them all out. I'll show you what I'm talking about. All right. Part B says graph and state the coordinates of A prime, B prime, C prime, which is the image, meaning after we do this reflection, of ABC reflected over the x-axis. So we're going to reflect over the x-axis. And those are going to be A prime, B prime, C prime. Now, if we remember the rules, a reflection over the x-axis means to change the sign of the y value. So I have the point 2, 0, and that stays 2, 0 because I can't change the sign of a 0. I just leave it alone. 3, 4 becomes 3, negative 4. So I change the sign of the y value here. And C becomes negative 4, negative 5. So I'm going to graph these 3 points and we'll see what it looks like. So here is A prime. Then we have 3. Negative 4 is B prime. Then we have negative 4. C prime here. So this is A prime, B prime, C prime. Now one thing that I do want to point out here is this has a fancy name to it. Since the point has not changed at all, this is actually called an invariant point because it has not moved. It stayed in the same spot. So that's just an important vocabulary word that comes up from time to time. So just be careful if you see that. If any question asks you about an invariant point, it means a point that does not change even after the transformation takes place. All right, and then the last thing we're going to do is we're going to do part C here. That says graph and state the coordinates of A double prime, B double prime, C double prime, which is the image of A prime, B prime, C prime, after reflection over the line y equals x. So I'm going to take these 3 coordinates, I'm going to write them down here. It's A double prime, B double prime, C double prime. And if I remember my reflection rule for the line y equals x, I just flip the order. So from 2, 0 becomes 0, 2. From 3, negative 4 becomes negative 4, 3. And from negative 4, negative 5 becomes negative 5, negative 4. And I'm just going to graph these so that we have it done here. 0, 2, Negative 4, 3, that's B, this is A. And then negative 5, negative 4, C double prime. So these are my 3 triangles here. And it's important that I graph them because each step of the way it did tell me to graph this triangle. Alright, so this is video 3. These are all the different reflections that you're going to need to know. I got a ton of practice for you set up in the rest of this packet. And at the end of this packet, you do have a mastery check on reflections. Alright, so make sure that you memorize these rules. Okay, these rules are very, very important, and they are not given to you on the Regents exams. You do have to memorize these. Alright, so I'll see you guys for video 4. We talk about translation.